Hello and welcome to my channel. In this video, I will be explaining about thermite welding process. Thermite welding process is a fusion welding process. So here we heat the elements and after fusion and solidification we get the weldment. So here the heat is applied externally. So the thermite welding process is also called aluminothermic welding. So here we are using aluminium powder and iron oxide, and by the chemical of these two elements we get the iron, the melted iron, which creates also heat near about 2500 degree Celsius. So it is a fusion welding process, joins metal, and it is applied where the electricity is not available and also the arc welding is not or gas welding is not accurate for that process. So here we are welding large sections of metals. Here we can't apply the gas welding process. So here we are commonly join steel rails or heavy sections. The heat is produced from an exothermic chemical reaction. The chemical reaction is occurring and we are getting the heat. The chemical reaction between a metal oxide, the metal oxide is usually taken iron oxide and the aluminium powder. So when we ignite these two elements, the chemical reaction occurs and a very high temperature creates the chemical reaction. So here we get near about 2500 degrees Celsius, which melts the joint, and after solidification we get the thermite welding joint. So how it works? So here we can see the process. Two men are working and this is the process is done and welding is done at this point. So we have to clean and align parts like rail ends, and we have to create a refractory mold around the joint. And when the refractory mold is created, a crucible with thermite mix. The thermite mix contains iron oxide and aluminium powder. We ignite it. After ignition, thermite reaction occurs and produces molten steel. Molten steel comes from this iron oxide. The iron become molten and the extra chemical reacts as slag. The molten steel flows from crucible into the mold by gravity. When the molten metal is filled the joint, then it cools, and after breaking the refractory mold we get the weldment or welding joint by the thermite welding process. So in this figure we can see the thermite welding process clearly. So this is crucible and this is mold, and here we have put the composition of aluminium and iron oxide. So when aluminium and iron oxide is ignited, in this figure we can see the ignition process. Ignited, heat is generated, and this iron melts and fills the section. This section fills the section, and after fully filled we get the welding joint. The molten iron flows through this section by the help of gravity, and these are the slag pans. This one and this one is slag pan. The slag comes over through this. When the chemical reaction is done and this portion is fully filled, the slag overflow from this and fills these pans, and also this is rail section. So after the solidification has been done and it cools down, we break this crucible or this refractory section, and after breaking this we get the welding joint, which is not finished enough. So we have to cut the extra portion and we have to grind the unfinished section, and we get the rail section joint, or we get a mega welding joint. So this is thermite welding setup. So what are the advantages of thermite welding process? So this is very high fusion temperature and produces involved strong welds. No external power source required. So here we are not using any kind of gas power source or electric power source, and this is very portable and ideal for field or rail repairs. This is good joining large cross section like rail section, heavy section, and produces metallurgical bond. So these are the advantages. Also this has some limitations or disadvantages, mostly limited to certain metals, commonly steel or iron. Other material or other metals can be welded using this method. Single use crucible and mold for each weld. So we have to create every time the crucible and the mold for each weld we want to join. So this is very time consuming, and it is very time consuming to prepare first time, and every time is first time for this process. And it requires experienced operators for quality. If the welder is not experienced, then the welding quality will be very poor and can produce porosity or inclusions if not done correctly. Also, if the operator is not trained, then it may produce porosity and inclusions. So the operator must be very skilled operator, and it is harder to control heat input. So we have to face difficulty to control the heat. We are able to control the heat in arc welding process, but in this process the heat control is very risky. We will see the applications of this thermite welding process. So joining railway rails, heavy section repairs, and situations needing where portable and power free welding, where we want to weld without any power, we can use this thermite welding process. So in this video I have discussed about the applications, disadvantages, advantages, the working setup, the working principle, and the definition of thermite welding process. Hope this video was useful for you. Thank you for watching this video. For more updates, subscribe this channel and hit the bell icon.